I want to talk briefly about this last problem on your Delta Math assignment for this week. And really, it's nothing new based on the last few problems that I've made videos on. Really, it's just putting everything together and actually visualizing the graph based on the sign chart. So here's what you need to do to get full credit on this and to be able to move past this question. You're going to need three things. First, you're going to start how we always start when we're graphing polynomials. You need to find all of the x-intercepts, right? And again, I feel like we've covered that pretty well. If you need more help, let me know. Send me an email and we can talk about it. But for now, let me just summarize. What are our four x-intercepts from our 1, 2, 3, 4 linear factors in this polynomial? We'll have 1 at 0, 0 from the first factor. We'll have 1 at -3, 0 from our second factor. We'll have a third one at 4, 0, and we'll have a fourth one at 6, 0. Those are our four x-intercepts, and that's where we start. We know that to get full credit, we'll need to touch the x-axis here, there, there, and there. What do we need next? Right, next, we need the sign chart. This is going to help us visualize where the function is. Is it positive in different intervals, or is it negative, right? So real quick, again, I'm going to spare the work just to keep this video short because I'm mainly interested in how we interpret the answer for now, right? If we imagine our x-axis and we imagine our intercepts on that axis, so we imagine -3, 0, 4, and 6. Here is what you should get for the signs on this sign chart, right? Left of -3, the function is going to be positive, meaning the function is going to start up here until it gets to that first x-intercept, right? Notice we have an even multiplicity root, so the function is going to bounce, meaning it's going to stay positive between that and the next x-intercept, so it should come up like that, right? It comes back down for the next intercept, which is again an even multiplicity root, which means again that we should get a nice bounce, which means that our function will stay positive between 0 and 4, right? Now what happens? If you plug in a test point, for example, +5, you're going to get a negative answer, which means that between 4 and 6, the function dives down, comes back up to hit that last x-intercept. And then what's the sign of that last x-intercept? Or to the right of it, I should say. It becomes positive from there, which means the function is going to cross back through and continue on up towards positive infinity on the right end of the function. Okay. Now, the last thing that we need to get full credit on this is we need to find the y-intercept of this function. Okay. And to find the y-intercept of this function, or any function, remember it's a straightforward process. The y-intercept is just the point where the function crosses the y-axis, and every point on the y-axis has one thing in common, right? Every point has an x-coordinate of 0. So anytime you want to find the y-intercept, you need to just plug in 0 for x, right? And see what you get. When you draw your graph, you're going to make sure that you kind of come as close as you can to that y-intercept. Otherwise, Delta Math will not give you full credit for it. In this case, we got lucky because actually our y-intercept and our x-intercept happen to be the same thing. They both happen to be at 0. So actually, one of our x-intercepts should be given to us. Okay. In any case, let's graph this out and make sure that it works with Delta Math and that we are all squares. So again, the key points, we need to make sure we've got the general shape right. We need to make sure that we hit the y-intercept, and then we'll be good. So I start up top on the left, touch the x-axis, bounce off of it, come back down, bounce again at my next intercept. Where am I going? From here, I'm going up and back down to +4, down and back up to cross at +6. Function continues. And how did we do? Okay, so we find the y-intercept, right? We find our x-intercepts, we make our sign chart, and we sketch our graph. Again, it doesn't have to be perfect. You just have to hit the most important points. The x-intercepts,